The NCLab 2020 webinar series is funded through a grant from the Institute for Museum and Library Services and provided to the Nevada State Library Archives and Public Records System. The topic of Webinar 8 is 3D Modeling Unit 1. Today we're looking at 3D modeling, and in this session we're going to look at Unit 1, and then the one that starts at 2:30 we'll look at Unit 2. The 3D modeling, it's this nice junction of learning how geometry works in 3D and computer-aided design and programming. So it builds all three of those skills, but primarily what it's building is visual spatial reasoning. And this is something you very much need in engineering and in design. So I'm going to go to the document, and it uses a language called PLaSM, and PLaSM's based on Python. It's got a C++ engine underneath it as well, all nicely hidden from the viewer. The code is very simple. It reads like English, so I'm going to blow that up just a little bit so you can see it. I don't know if 400 is going to be too much. It might be. Okay, there we go. So this is the code on the left-hand side, and you're just giving an object any name. The only rule is that you don't make it all capitals, and it's usually not a good idea to make it a keyword either, because that gets confusing. But in this case, it's simply two letters, SQ. When you name objects, you try and make the names functional so they make sense later on in the program. SQ is easy to type, and it just stands for square. The command, the keyword command here is square, and you'll notice it has a number after it in parentheses, and that is a parameter. And a square as a geometric object is very simple. All four sides are exactly the same length, and we already know all squares have 90-degree angles, so we don't have to ask for that information. The only information we need to ask for is the length of the side. So that's what we put in the parentheses, is the length of the side. And then there's a program underneath that will generate a square given that a little additional piece of information. So it requires a parameter, and we give it an argument of 1 to satisfy that parameter. So now that we have an object called square, we can do things to it. And a very simple thing you can do to a square is color it. So this is a verb, color. It's also a keyword that calls a function. We're going to color a square black. And then the last thing we need to do is show the square. So that's how it reads. It reads just like English. Object SQ is a square of size 1, color object SQ black, show object SQ. And then this is what it's going to look like. It's just a little black square, and it's nested right here on the origin. Shapes by default either have a corner right on the origin of the XY axis, in other words 0, 0, or if it's an object that's created by a radius, it'll be centered on that. I'm going to go back to our normal size. Let's see, fit width. There we go. So that's basically how the language works. But it's like Carol and anything else. Simple is what you build on. And in the very first unit, all we're going to focus on are two-dimensional objects and manipulating them. By the time you get to the end of Unit 4, towards the end of Unit 4, now you're building objects that have quite complex characteristics and several parameters. And in this case, this is a spiral handrail on a staircase. And this is all information that's given in the instructions, and it gets written into a spiral command, which will have parameters, but there'll be quite a few of them. With 3D modeling, really encourage people to build as they go. It's fun. It really is fun to make objects in 3D modeling. And to get there, of course, they go to Creative Suite, and it's the second card, 3D modeling, and then within that there's two modeling languages. PLaSM is the first one. When they open up the PLaSM app, it comes with a default program. That default will build this cube with holes in it. So this can be stepped through, and I'll show you that in a moment. And a little bit about what they're learning is called constructive solid geometry. And it's a method of creating these models by combining basic shapes using geometric transformations. And if you remember from your middle school and high school math, transformations include translation, which is just moving it in one direction, rotations, so that's turning it, and reflections, which is mirroring it. And then you can use various Boolean operators to combine these shapes, and that's pretty neat stuff. Subtraction, to me, is one of the coolest, because you just don't think of subtraction in 3D geometric terms. You think of it as 3 minus 2 equals 1. But you can do some pretty neat things. This is the case up here of using subtraction to build a complex shape. The other fun aspect is once you start building models, you can export them as STL files for 3D printers. And an STL file, this will work whether you have a printer at home or you're sending your file to someone who has a printer. So that might be something that the libraries can still do, even though the clubs are at home. If people send in their STL files and you're comfortable with printing them, you can print them out. So that's the nice thing about a file. You can send it anywhere. All right, in Unit 1, like I said, we're sticking with 2D shapes. And there's just a note on how everything is numbered again and how you get points, just like all the other NCLab courses. You get points for completing each level. You get points for writing the code efficiently, for getting it submitted correctly on the first try. You do have unlimited tries. You do get hints to help you understand the task and fill in the blank templates to see the coding structure, but they are both costly in terms of points. Excuse me. And then you have quizzes every section, and you can retake those to improve your score. And then in section 1, there's our square again, and we've already run through this, but this is where we start using the language, understanding how it fits on the XY coordinate plane and how each shape is built. By the time you get to section 2, now you're getting slightly more complex. So you're building shapes that are built from other shapes or that are built from points. And for example, this command ring, which creates a ring structure, has two parameters. There's the inside radius and the outside radius. And what the program is actually doing is it's subtracting one circle from another to make the difference, which is the ring. And then triangles and quadrilaterals, because their shapes are a little harder to define, we use their vertex points, the points on the vertices, to define them. And so those are all, again, XY coordinates. And you can see we write it as a triangle being made of a point with its XY coordinates, another point with its XY coordinates, and a third one, and a quadrilateral just adds another point. There's a simpler way to write this, but I think when people are learning, if they actually have to build it by stating these points, it helps with the learning. There's a quicker way to do it with a list, but we won't go into that right now. So since we've played a bit with ring, then you're also going to learn a little bit about subtracting shapes to make new shapes. Then in section 3, now we're messing with some parameters on circles. So, and if you remember from 2 weeks ago when we looked at visual intro to Python, we were doing this with for loops. So in this case, you don't have to write any complex for loop. You just simply give it a second parameter. Let's blow that up a little bit so you can see it. So the circle has a radius of 2, and you can count 2 units there. But the second parameter tells us how many sides that circle has. And in this case, it's 8, and that makes an octagon. The way circles are rendered, they're really regular polygons with a lot of sides. So they're not true smooth circles. We just have so many little sides that they look smooth. So in this case, we're just tamping it down to only 8 sides. And I'm going to go back out a little bit here. And then boxes are another method of creating a shape, and you're using, in this case, you're using minimum and maximum values of X and Y. And then when we get into 3D, box can create a box with X, Y, and Z values. So you can see here, this is where you have to be a little careful, because what you do is you list, let's bring that up again, you list X1, X2, and then Y1, Y2. So it's not a coordinate pair anymore. These are lists of your minimum and maximum X and Y values, and that's going to create a box. And it automatically positions it anywhere you want on the grid. You're no longer constrained by it building in a default position off the origin. You can also make them with decimal values as well, so you can make a pretty refined shape. Okay, so then what's exciting is you're now taking your 2D shapes and turning them into 3D shapes using what we call the prism command. And in the turtle course, we were using the word extrude, or we're adding a height command. Here we're creating, so we have a base, which is a ring. That's your 2D base, and any shape can be a base. Any composite shape or anything can be the base. And then you're creating another object. In this case, we're calling it washer, and washer uses the prism command and calls the base object that we've already created as the base, and then adds a height of 1. So that's in your z-axis direction. You can see the blue line is the z direction. And now we have something that looks like a washer, a steel washer. And so section 4, now we're going to start moving things around. And the easiest command to learn is translate, or we just write it as move in PLaSM. And you can move just X, just Y, or you can move both directions at once. And when you get into 3D, you can move it X, Y, and Z directions. So this whole section uses a board game. We used to call it Parcheesi. Dr. Solon refers to it as Ludo. There's lots of variations on it. Sorry is another one, where you're trotting around the board, and at the end of the day, you need to get all your markers to the end of your own path home, and whoever gets all their markers there first wins. So it's a nice way to teach XY coordinates, and it's used throughout this section to do that. And then finally, we start putting everything together. So section 5 takes all these ideas, all these ways of building, and builds more complex patterns. A lot of these are partially built, and you just need to add a piece because you're just learning how to do that thing. And then at the end, you also learn how to create copies of objects. So this is nice. If you've built a complex object and you want to make other pieces that look like it, you can use it as a template, and then when you manipulate them, make changes to them, your original is not being changed. So that's it. That is basically Unit 1. It's all 2D. And let's take a look at how that looks in here. We'll run some code. Of course, like a lot of the courses, we have instructional videos, and basically that runs you through the procedure. There's some examples, and then this whole first section is has a C theme, so there's lots of context there. Okay, so let me blow this up a little bit. And I'm going to, so you can see the code over here. Okay, so I'm going to step through this. And you can see the outside of this flag has already been created. So we're just going to add this black center to it. So when I press the step button, I don't see anything yet. I press it again. There is the square that I just created. And you can see it's gray. That's just its default color. But now when I color it, it turns black. And then finally, the program's finished, everything's displayed, and I can hit the stop button. Just run that through again. Once you run it, then it can be submitted for grading. So this is something you can emphasize if you're running a club, is have them try and work out all the bits and pieces with the run button or the step button. And then when they think they have it all, they can run it and then submit it for grading. So there's no penalties for going through this over and over again before you submit. And think of that as, this is again real life. If you have a project, what do? You go back and you revise it and edit it and fix mistakes and make changes and so forth. And then finally you print it out, create a PDF, share it, whatever. That's your submit button. And you want it to be pretty good at that point. So when I submit it, then of course I'm going to get graded. And there's all my millions of points because I've run this so many times, and the score. So let's just take a look at a triangle here. That's rings. I'm going to go to triangle because it's a little more complicated. Okay, this is another flag. And there's a triangle. And this is where we have two triangles, and there's a yellow triangle with these points, and then a red triangle with these points. And it doesn't really matter what order they're created in, as long as they're the right points. So let's just step through that. There's our first triangle. That's the yellow one, and now it's been colored. And now we're creating the second triangle and coloring it, and then this is the final display. So let's skip over to section 3, and I think the prism command is this one. Yep. All right, this is the washer that we talked about. And this is actually a little different. This is a wooden mast. And let's just go step through it again. So that's created a plane to work on. And now we actually have created, oh, that's the first circle. That's right. That you can see it has a radius of 3. And then we're going to subtract the second circle from the first one. And you can see that second circle is an octagon. And this is what happens when you subtract 2 units. And then to make the mast, we just simply extrude it. And now you can see the mast. So that gives you an idea of how this unit works. And By the end of it, of course, you're building complex objects. Oh, just before I go, I'll just show you where that is in Creative Suites. There it is. 3D modeling, PLaSM. This is this cube, so we'll just run through this real quick. Okay, and you'll notice that on the code here, there are all these lines that are preceded by hashtag, sign, pound, symbol, whatever you want to call it. And those are comment lines. So this coding in the 3D modeling can be commented just like you do in Python or Carol. So there's our plane, there's our first cube. Now we've created a cylinder. Now we move our cube. Now we move our cylinder. Now we make a copy of the cylinder, and we're going to rotate that copy. So you can see there's the original and there's the copy. And then we're going to copy that one again and create a third one. So now we have 3 cylinders going through the cube. And then this is the little bit of magic. Now we subtract all 3 cylinders from the cube, and that creates that final object. And we give it a nice gold color, and we're done. So that's how that works. Questions on this? All right, guys. Well, I'll tell you what, we have 5 minutes for a coffee break, and then we can come back and look at the second unit. Can you create your own program? Oh, yes, absolutely. You can create your own program here. What I recommend before you start is to clear the file, just erase the code. Okay, and save in NCLab, test May. Just going to give it a name here. All right, so now you can see the file name's changed. I just called it test May. You can edit this text here, just with the text box, etc. Okay. So that's just a little HTML editor. You can make some preamble on it, and then you can just start writing your code in here. And we can color SQ red and show SQ, and then run it. And there it is. There's our red square. So now if I want, oops, what did I do here? There we go. Now if I want, I can share that file. So you can see here, I can share online, and I can select the privilege of the viewer. I can just have people view it. I can have them run the code. And now you can see I have a link, and I can copy that link to anywhere. You can post it on social network, but typically people just share the link. So that's now a linked file that I can share. So there you go. That's the fun part, is making models. And instructor resources. And if we go to 3D modeling, you can see all kinds of projects. And again, these are pretty closely tied to the course. So the level of difficulty is pretty much matches what they learn in each section. Yes, you can edit the file at any time. And again, you can, if you rename it, so you could, let's say you have a file that's a really nice template for a bunch of projects, then you can always use save as and create another file name and preserve your template, because it does auto save. So yes, you can save it, and then let me see. Okay, I'm going to close that. All right. You can export it as an STL file from the viewer window. All right, I am going to stop sharing, and I'll go ahead and end the meeting, and then let's get back together in 5 minutes, and I'll start the next meeting.